Petrol enemy in your 2D game. With this beginner friendly Unity tutorial, I will show you how to create a simple enemy patrol system using C#. Thanks to my amazing Patreon supporters Sikario and Alexandra Bogdyash, and a special thanks to Ahmed Soria Pimentara for the higher tier support on my Patreon page. Now let's jump right into the tutorial. As a step, we will move this enemy to the left or right direction. For that, we're gonna create a script. So select your enemy in the hierarchy, click on add component, new script in the bottom, name the script whatever you want, name it to something like petrol enemy, then click on this create and add in the bottom, and then open up that script. I have created that script inside my enemies folder, so I'm gonna attach this script to my my enemy 2 game object. So let's open up our petrol enemy script inside Visual Studio by double clicking on it. So what we need a reference to this rigid body 2D of this enemy, because this rigid body 2D is responsible for adding velocity, basically the linear velocity of our enemy. So we need a reference of it. So let's go over to our script and let's come at the top of our class and let's make a public, and the component we're looking for rigid body 2D. So we're gonna type this rigid body 2D and let's call it RB, short for rigid body 2D, and let's save our script. Let's go over to Unity editor because we need to drag the reference, and after having the reference we can move our enemy. Let's select our rigid body 2D and we're going to drag it over to this RB slot, and now we can see we have the enemy to rigid body 2D component, basically this reference, and we are ready to add the linear velocity. So let's go over to our script, and to add the velocity we're going to use this RB dot linear velocity. Basically we're just going over to rigid body 2D of our enemy, then linear velocity, and we're gonna set equal to velocity. So we're gonna set equal to transform dot right, or which direction we basically want to move. So we're gonna set transform dot right, and transform dot right basically means which direction this enemy is looking. So we can see this enemy is looking to the left direction, but this arrow represent, and we can see this arrows facing to the right direction, but I want to move this enemy to the left direction, so I'm gonna put minus in front of it, and that's all we have to do. And we can just close that up with semicolon, but we just want to move a little bit faster, so we can simply multiply with some number. So let's make a variable for our speed as well. So let's come at the top of our class and let's make a public float, and we can call this one speed or move speed. Let's call it move speed, and by default I'm gonna give something like 2 unit 2f, and we're gonna multiply this direction with our move speed. As soon as our game started, we can see this enemy is moving to the left direction. So if the enemy is somewhere around here, what we really want to do, so if I unpause my game, we basically want to flip this enemy to the right direction. So basically we're gonna create a point somewhere around here of this enemy, and we're gonna shoot out a ray from that point, and if that ray don't collide with this ground, then we're gonna flip this enemy to the right direction. To do that we need to shoot out the ray, so we have to use a function called physics2d.raycast. So let's go over to our script, and we have to use this physics2d.raycast function, and this raycast function, as a first parameter, it will take the point from where we want to shoot out the ray, and the second thing, it's gonna take the direction. So we're gonna use vector2 dot down. It means -1 in the y, so it will be down, and x in the 0. So since we want to shoot out in the down, so that's why we're gonna use vector2 dot down. And the third parameter, it's gonna take the length of the ray, and the fourth parameter, it's gonna take the layer mask, basically which game object we just want to check with. So since we want to check with this ground, so I have to assign this ground as a ground layer. So we need those variable. So I'm gonna make this one comment by double forward slash, and we do know that comment don't interrupt our code. So let's go to top of our class and let's gather those variable. So the first thing, we need the point. So we're gonna make a public transform, and we do know that this transform is responsible for position, rotation, and in scale, and we can call it something like round checkpoint, something just like that. And we can skip the second variable, which is the direction, because we're gonna use the vector2 dot down. But we do need the third parameter, which is the length of the ray, or basically the distance. So we're gonna make a public float and we can call it distance or ray length, and by default I'm gonna set something like 0.2 unit, just like that. And the fourth parameter, we need the layer mask, so let's make a public layer mask and we can call it check layer target layer, but I'm gonna call it something like what is ground. We can see ground checkpoint and it says none transform, means empty, so we need to create that. So we're gonna select our enemy 2 in the hierarchy or the enemy. We're gonna right click on it. Let's create an empty child game object and we're gonna name it to something like ground. Let's call it ground checkpoint, just like that. And we're gonna choose the move tool in the scene view and let's move it in front of this enemy. And if you want to choose an icon, then you can go over to inspector, then click on this cube icon and you can choose the gizmo. So I'm gonna go with this yellow one. And now we're gonna select our ground checkpoint and let's drag it over to this ground checkpoint field. Now we can see we have the point, and what is ground? It says nothing, so we're gonna choose our ground. And before you choose your ground, make sure you assign your ground as a ground layer. To do that, select your ground game object. So in my case, I will select my ground tile, then go over to inspector. In the top right side layer, it will be default, so just click on it and then click on this add layer and create a new layer. Basically name it whatever you just want to name it, and make sure you select the game object once again and assign with the layer which you recently created. And you can see I have assigned this ground as a ground layer, as you can see. And now underneath my petrol enemy script, what is ground? I'm gonna choose my ground layer, and now the ray only gonna check with this ground. And let's go over to our script and we're gonna remove these two forward slashes by now, and we will use this physics2d.raycast function. So this function as a first parameter, it's gonna take the point. So let's pass our ground checkpoint dot position because we need the position. And the second thing, the direction. So we're gonna use this vector2 dot down. Vector2 dot down means -1 in the x, basically vertically -1, so it will be down, and 0 in the x. And the third parameter, we need the length of the ray, basically the distance, so we're gonna pass our distance. And the fourth argument, it's gonna take the layer mask, so we will pass our what is ground. And we do know that what is ground, we have chosen that ground layer, so it's gonna create the ray. It's gonna shoot out there from that point with a specified distance or the ray length as we specified, which is 0.2, we can see. So it's gonna shoot out. Let's suppose the ray collide with this ground, then this function over here, it's gonna give us a true value. And let's suppose the ray don't collide with this ground. So let's suppose the enemy is somewhere around here, so the ray that we shoot out from this point, it's not gonna collide with this ground if the enemy is somewhere around here. Then this function right over here, it's gonna give us a false value. So we can store it into a bool parameter. So since this is a raycast, so we're gonna put it in a variable, and variable type should be same. We can put it into a bool as well, it doesn't matter, but I'm gonna put it into a raycast hit 2d because this is a raycast. So I'm gonna create a raycast hit 2d parameter and I can call it something like hit info, and let's set equal to this short for hit information. So this hit info can be true or false depending upon if the ray is really colliding with this ground or not. And now what we're gonna do, we're gonna check that. So let's use the if condition and let's make first bracket and some curly brackets, and we will check that if our hit info is equals to false, it means the ray is not colliding with this ground. It means our enemy is somewhere around here, and we can see which is shooting out the ray from here, so it's not gonna collide with this ground. So it means we need to flip our enemy. For now I just want to print out a message, so I'm gonna say something like, so for printing out message we're gonna type debug.log and we will say something like flip enemy, just like that. However, we're not able to see the ray, or to see the ray or to draw the ray we have to use another function, and that function is onDrawGizmo selected. So we have to use this function called onDrawGizmo selected, and make sure you just type as I did over here, else it's not gonna work. And you can remove this private, so it doesn't matter at all. And before we draw the ray, we need to check, we have to check that if we assign it that ground checkpoint or not. If we do, that means we are ready to draw. So before we draw, we're gonna check. So let's use the if condition once again, and we want to check that if our ground checkpoint is not equal to null, it means it's not empty at all. It means we just assign it our ground checkpoint. It means we are ready to draw the ray, and to draw the ray we're gonna use this gizmos dot draw where sphere function. So let's use this gizmos draw, not where sphere. I really apologize. It will be draw ray function instead, and this function as a first parameter it will take the position. So I'm gonna pass our ground checkpoint dot position, and the second thing it's gonna take the direction. So we're gonna put vector2 dot down, and we can multiply this direction with the length of the ray, so we can see that. So we're gonna multiply with distance, basically means the length of the ray. And before we draw, we can choose the color as well. If you want, you can just set the color. So I'm gonna set color. To set the color, we're gonna use this gizmos. So let's use this gizmos dot color, and the color you would like to draw with. So I'm gonna set equal to color dot yellow, because I want to draw with yellow color. Now the ray is visible, but it seems way less. So I'm gonna make the distance something like this much, something like 0.36. And let's select our console tab, and we will quickly play our game, and that message should be pop up, and we can see once the enemy was over here, the message got pop up inside our console tab says flip enemy, because we can see this ray is not colliding with this ground at all. So instead of printing out message, we really need to flip this enemy. And to flip that, if we go to transform, rotation or Euler angles, and in the Y if we set it to minus 180 or 180, we can notice it flips to the right direction. So what we have to do, we need to set this Y to minus 180 or 180, basically the Euler angles. To do that, let's go over to our script, and instead of printing out message, we're gonna flip our enemy. But before we flip our enemy, we're gonna create a variable in order to keep track of which direction this enemy is looking. So we can see this enemy is looking for now left direction. So let's create a parameter to just keep track of it. So let's go to top of our class. So we're gonna make a private bool parameter which can be true or false, and let's call it something like facing left, just like that. And in the start of the game, basically inside my start function, I'm gonna set facing left equal to true, because in the start of the game we can see this enemy is looking to the left direction, so that's why I just set it to true. And now over here we checking that if the ray is not colliding with the ground, ground means the enemy is somewhere around here. At the same time, I just want to check if this enemy is looking to the left direction. If the enemy is over here, means the ray is not colliding with the ground. At the same time, I'm gonna check. So let's use the if condition. If our facing left is parameter is true, we can set equals to true, or if we just leave it like this, it also means true. It means we are ready to flip our enemy to the right direction. To flip that, we will go to transform of our enemy. So let's go to transform, then Euler angles, and we're gonna set equal to a new vector 3, because this Euler angle just gonna have the x, y, and the z. So x comma y comma z. So in the y, what we're gonna do, we're gonna put minus 180 or 180. So I'm gonna put minus 180, so it's gonna flip to the right direction. And in the x, I'm gonna put 0f, and in the y, I'm gonna put 0f. I don't want to play around with the z and the x axis. And after flipping this enemy to the right direction, what we need to do, we need to set the facing left parameter to false, because if we flip this enemy to the right direction, this enemy will be no longer able to look to the left direction. So after flipping our enemy, we're gonna set facing left equal to false, because now this enemy just gonna look to the right direction. And let's suppose the enemy is somewhere around here. So the ray is not gonna collide with these grounds once again. It means we need to flip our enemy to left direction once again, so the ray is not gonna collide. So the first thing, we need to check that if the enemy is looking to the right direction and the enemy is somewhere around here, means the ray is not colliding with the ground. So now else we will check if our enemy is looking to the right direction and the ray is not colliding with our ground, and we checking over here. If our ray is not colliding with ground, then checking the direction. So we can simply copy this line of code and we can paste it over here. And now what we have to do, we need to set back this y to 0. So if we select our enemy, then set this y to minus 180 or 180. As you can see, it's gonna flip to the right. But if we set back this y to back to 0, we can see once again it's gonna flip to the left direction. So what we will do, we're gonna set this y to 0. So what we're doing, else if our enemy is looking to the right direction, means this facing left parameter is false, means enemy is looking to the right direction. So in this movement, once again we just flipping to the left direction. Basically we set y to 0, and after flipping our enemy to the left direction, we need to set facing left parameter to true once again, because this enemy just gonna look towards to the left direction. So after flipping our enemy to the left direction, I'm gonna set facing left to true once again. We can see as soon as enemy was over here, it flips to the right direction, and we can see the y is 180, and it should flip to the left direction once the enemy is just gonna be over here, because this enemy is looking to the right direction and the ray not gonna collide with this ground. So it should flip back to left direction. Let's see that. And indeed it's flipping to the left direction once again. So it's basically patrolling around this ground, as you can see.